The first law of thermodynamics for a control mass undergoing a cycle. The first law of thermodynamics. The first law of thermodynamics states that during any cycle, a system control mass undergoes the cyclic integral of the heat, the cyclic integral of the heat is proportional to the cyclic integral of the volume. To illustrate this law, consider as a control mass the gas in a container shown in this picture. Let this system go through a cycle that is made up of two processes. In the first process, work is done on the system by the paddle that turns as the weight is lowered. So, the first process is work is done on the system by the paddle that turns as the weight is lowered. Let the system then return to the initial state by transferring heat from the system until the system has been completed. The system returns to its initial state by transferring heat from the system until the cycle has been completed. Historically, work was measured in mechanical units as of force times distance. Work force times distance, such as foot, pounds, force, or joules. And heat was measured in thermal units such as the British thermal unit or the calorie. BTU, British thermal units or calories. Measurements of work and heat were made during a cycle for a wide variety of systems and for various amounts of work and heat. When the amounts of work and heat were compared, it was found that they were always proportional. Such observation led to the formulation of the first law of thermodynamics, which is in the form as written. The cyclic integration of heat is proportional to the cyclic integration of work. The symbol, which is called the cyclic integration of heat transfer, the cyclic integral of the heat transfer. And the cyclic integration of the work represents the net work during the cycle, net heat, net work, and J is proportionality factor. That depends on the units used for the work The basis of every law of nature is experimental evidence, and this is true also for the first law of thermodynamics. Experimental evidence. Many different experiments have been conducted on the first law, and every one thus far has verified either directly or indirectly the first law has never been disproven. As was discussed in the Chapter 4, the units for work and heat or any other form of energy either are the same or are directly proportional. In SI is the joule energy, such as work, heat, or any others. Joule J. In the SI unit, and in the English unit, the basic unit for work is foot-pound force, and in the British unit, foot-pound force, and the basic unit for heat transfer is the BTU, British Thermal Unit. Did the first accurate work in the 19th century on measurement of the proportionality factor J, which relates these units. Today the BTU is defined in terms of the SI units. 1 BTU equals to foot-pound force. This unit is termed the International British Thermal Unit for much engineering. International British Thermal International BTU. For much engineering work, the accuracy of other data does not warrant more accuracy than the relation stated here, which is the value used the English unit in the problem in this book. Because these units are equivalent, it is not necessary to include the factor J explicitly in the relation for the work. For this relation, but simply thus recognize that for any system of unit, each equation must have consistent unit throughout. Therefore, we may write the cyclic proportionality of work and heat in a system as this relation, eliminating the J from the relation. First law of thermodynamics, which can be considered as the basic statement of the first law of thermodynamics. The next section is the first law of thermodynamics for a change in a state of a control mass.